This video will be one of the most important videos that you will learn about R. We're going to learn how to summarize and use group by. The last function we're going to learn is summarize. So we can summarize flights. We want the delay to be the mean of departure delay. And then NARM equals true. So we'll come back to this last part, that NA.RM equals true. But what we're doing is we're looking to get the mean of the departure delays. So this will give us the average of all the departure delays from our flight's data frame. So you can see it returns 12.6. Summarize isn't terribly useful unless we pair it with group by. So this gives us the total overall average, but if we want to group it by, let's say, the year, month, and day. So let's say what's the average delay per day? We can use a group by. This changes the unit of analysis from the complete data set to individual groups. When you use Dipler verbs on a group by data frame, they'll be automatically applied by groups. So let's take a look at the by day group by. So we're going to create a variable called by day, and we're going to say it's group by flights year, month, day. So this is just a variable that we're going to insert into our summarized function. So we have a group by. Now we pull back our summarize function, and instead of saying flights, we just say by day. So what this does, it replaces the flights with group by flights year, month, day. And then we hit enter, and what this will do is for each day, it'll tell you the average delay. So you can see which days have the highest average. Together, group by and summarize provide one of the tools that you'll use most commonly when working with R. Grouped summaries are super useful in really analyzing your data in different segments. Before we go any further with this, we need to introduce a powerful idea, and that's the pipe. So we can combine multiple operations with pipe. So imagine we're trying to get to the following group by. So let's do by destination. And we want that to say group by flights destination. By destination, group by destination. So all this does, it groups it by the destination in your flight's data set. Next, we want to summarize the group by the destination. So let's go ahead, and destination is unknown because there's no column called destination in our data set. It's just dest. Next, we want to look at the delay. So to get the delay, we summarize by destination, which is a variable we just created. And then we want the count of n. So we want to see by destination how many values do we have, and then we want to calculate the average distance, which is the mean distance. NA.RM equals true. We'll review that at the end of this video. And then we also want to calculate the delay, which is the mean of the arrival delay. And RM equals true. And then lastly, what this does, it calculates the delay for us. We can hit enter. And now we want the delay to be, we want to filter the current delay with count greater than 20. Destination does not equal null. HNL. So What we've done here is first we've grouped by the destination. We just want the number of flights for each destination. And then we only want to get the flights that have more than 20 flights. And we don't want to include H and L. So we enter, and now what we can do is we can plot this data set. So let's go ggplot. Data equals delay, mapping equals AES, x equals dist, y equals delay. And then we also want the geom point to be the size equals the count, and then the alpha equals 1/3. And then lastly, we'd like the geom smooth, which we used earlier, to be SE equals false. All right, this gives us a nice summarized plot of the data set. You can see there are 3 things we did to prepare this data set. First, we grouped by the flight destinations, and then we summarized to compute the distance and average delay and the number of flights. Finally, we filtered to remove any noisy points and Honolulu Airport, which is always twice as far as the next closest airport. So that's why we removed that data frame, that airport. The code is a little frustrating to read and write because you have to give each intermediate data frame a name, even though we don't care about it. Naming things is hard, so this slows our analysis. There's another way to tackle the same problem with pipe. The pipe function makes our data look way better and much easier to use. So what this does, it just passes the data frame onto the next line in the code. So we'll start from scratch. We'll go ahead and type in delays, and we'll call that flights. And then here is the pipe we're using. And then we want to group by destination. And you just hit a space between the pipes, group by destination. And it automatically knows that the flights is being passed. And then we want to pass this same value using a pipe to our summarize function. Group by destination. We close the parentheses and then create the pipe again. Summarize the count of values. And then we want to say the distance is the mean. Again, we're calculating that. Distance is the mean. Dist equals mean of the distance. .rm equals true. And then we want the delay to equal the mean of the arrival delay. NA.rm equals true again. And then we close that, close the parentheses, and we tell it, again, we add another pipe to pass that parameter on to the final function, which is the filter. So we want the count greater than 20. The destination does not equal Honolulu. All right, so this focuses on the transformation and not what's being transformed, which makes the code easier to read. You can read it as a series of imperative statements. Group, then summarize, then filter. As suggested by this course, a good way to pronounce this function right here is pipe. So you can say then, and another way to use this in American English is to say then. So flights, then group by, then summarize, then filter. So Behind the scenes, these functions turn these into f equals xy. So it just keeps passing the parameter onto the next value. You can use a pipe to rewrite multiple operations in a way that you can read left to right, top to bottom. We'll be using piping frequently from now on because it considerably improves the readability of our code. So we want our code to be easy to read and easy to work with. Working with a pipe is one of the key criteria for belonging to the tidyverse. The only exception is ggplot2. It was written before pipe was discovered. Unfortunately, the next iteration of ggplot2, ggvis, which does use pipe, isn't ready for prime time yet. So we're not going to get into using pipes with ggplot2. So now we have this delays data frame, which is the same as the previous data frame that we had with delay, the previous delay data frame. And this is much easier to use, much easier to read and much easier to write. So same fun, we have 1, 2, 3, 4 lines of code summarized into one line of code. So it's much better in the long run. Now lastly, we were talking about this na.rm equals true. You may have wondered what that argument was. So what happens if we don't set it? What happens is we get a lot of missing variables. So let's take the last code and let's pull in, just type in the flights, and then we want to remove the na equals true. If we do that, we get a bunch of nulls or missing data. That's because aggregation functions obey the usual rule of missing values. If there's any missing value in the input, the output will be missing value, will be NA. So you can see that for ABQ, Albuquerque, I believe, all the values were there. But for most of the other airports, there was at least one value missing. Fortunately, all aggregation functions have the na.rm argument, which removes the missing values prior to computation. So always use that na.rm equals true to clean up your data. Obviously, you want to review your data and make sure it's a decent sample size. But once you're comfortable with that sample size, you can start using the na.rm equals true, and that will remove any unknown values from your summaries. In the next video, we'll look at counts and how to plot those to really understand your data better.